Y'all, I need you to sit with this number for a second before I explain anything else. Over the next several days, more than 100 million people across this country are going to wake up under some level of heat alert. And based on what I'm seeing in the guidance this morning, the hottest, most dangerous days of this entire stretch haven't even happened yet. Most people assume the peak of a heat wave is whatever day feels worst so far. That is almost never actually true, and I want to walk you all through exactly why the real peak of this event is still ahead of us, why that matters so much for how you plan the next several days, and who is genuinely at risk if this pattern plays out the way the models are showing. It is Saturday, August the 1st, and let's start with the setup driving this, because understanding the mechanism is what's going to help you take this seriously instead of just treating it as another hot week. What we have in place right now is a strong, sprawling ridge of high pressure, sometimes called a heat dome when it gets this large and this entrenched, parked over a huge portion of the central and eastern United States. I've explained this mechanism on this channel before in the context of severe weather, but it's worth walking through again here because it's the exact same physical process, just producing a completely different kind of danger. Underneath a ridge like this, air is sinking from higher in the atmosphere down toward the surface, and as that air sinks, it compresses and warms, which is part of why ridges suppress cloud cover and rainfall at the same time they're driving temperatures up. Clear skies mean more direct sunlight reaching the ground with nothing to block it, and that sinking, compressing air adds an extra layer of warming on top of whatever the sun alone would produce. The combination is what allows temperatures to climb well above what you'd get from summer sunshine on its own, and the reason this particular heat dome is so concerning is that it is forecast to remain locked in place, essentially parked, over the same general region, for an extended stretch, rather than moving through and giving anyone a quick break. Here's the part that I think catches people off guard every single time a heat wave like this sets up, and it's the reason I opened this video the way I did. Heat domes don't produce their worst temperatures on day one, they build. Each additional day, the ridge stays parked in place. The ground itself gets hotter because soil and pavement and concrete are absorbing and retaining heat faster than the shorter nights are able to let it radiate back out. That means overnight low temperatures climb along with the daytime highs, and each morning starts from a warmer baseline than the morning before. So afternoon highs keep pushing upward even without the ridge itself intensifying any further. Meteorologists sometimes call this a heat waves building effect, and it's exactly why the third, fourth, and fifth days of an extended heat dome are consistently more dangerous than the first, even when the atmospheric pattern driving it looks essentially unchanged on a weather map. Based on current guidance, this event is forecast to be in roughly that day 4 through day 6 window over the next several days, which means, mathematically and physically, we should expect the most extreme numbers of this entire stretch still to come, not behind us. Let's talk about the actual numbers because I think specifics matter here more than vague descriptions of very hot. Across a broad corridor, stretching from the southern and central plains through the Mississippi Valley and into the Ohio Valley and mid-Atlantic, afternoon high temperatures are forecast to run into the upper 90s, to right around 105 degrees over the next several days, with some of the most persistently hot spots, particularly across parts of the southern plains and lower Mississippi Valley, seeing little relief even at night, with overnight lows only dropping into the middle to upper 70s in a lot of urban areas. I want y'all to sit with that overnight number for a second, because it might be the single most dangerous piece of this entire forecast, and it's the piece that gets the least attention. Here's why overnight lows matter so much, and this is genuinely one of the most important concepts in heat safety that most people have never had explained to them clearly. Your body needs a period of relief from heat stress to actually recover, and normally, overnight is when that recovery happens, as temperatures drop and your body has a chance to cool back down before the next day's heat begins building again. When overnight lows stay unusually warm in the middle to upper 70s instead of dropping into the 60s or lower, that recovery window essentially disappears. Your body goes into the next day already starting from a state of accumulated heat stress rather than a fully recovered baseline, and that accumulation compounds day after day across a prolonged heat wave like this one. This is a huge part of why extended heat waves become so much more dangerous and so much more deadly the longer they persist, even if the daytime peak temperature itself doesn't change much from day to day. It's not just about how hot the hottest hour of the day gets, it's about how little relief your body gets across the entire multi-day stretch. Now let's talk about heat index and why the actual air temperature alone doesn't tell the whole story, because this is another piece of the puzzle that I think gets underexplained. Heat index is a measure of how hot it actually feels to the human body once you factor in humidity, because humidity directly interferes with your body's primary cooling mechanism, which is sweat evaporating off your skin. In dry heat, sweat evaporates efficiently and carries heat away from your body effectively. In humid conditions, the air is already close to saturated with moisture, so sweat evaporates much more slowly, and your body's cooling system becomes dramatically less effective, even though you're still sweating just as much or more. Across a lot of the corridor I mentioned, particularly the Mississippi Valley, the Mid-South, and the Mid-Atlantic, humidity levels are forecast to stay elevated throughout this heat wave. And the combination of high actual temperatures with high humidity is going to push heat index values into the 110 to 120 degree range in the worst affected areas on the peak days later this week. That is squarely in the range the National Weather Service categorizes as extreme danger, where heat stroke becomes a genuine, imminent risk with prolonged exposure or physical activity, not just a discomfort issue. I also want to briefly explain a term that's gotten more attention from climate scientists in recent years, because it's directly relevant to understanding just how dangerous the most extreme humid heat events can become, and that's wet bulb temperature. A wet bulb temperature is essentially a measure of the lowest temperature achievable through evaporative cooling alone, and it accounts for both heat and humidity together in a more physiologically direct way than heat index does. Scientists have identified a wet bulb temperature threshold, generally cited around 95 degrees Fahrenheit sustained for several hours, beyond which the human body genuinely cannot cool itself through sweating anymore, regardless of hydration, shade, or fitness level, because the surrounding air is too hot and too saturated with moisture for evaporation to work at all. We are not forecasting wet bulb temperatures anywhere near that absolute survivability threshold with this particular event. I want to be clear about that so I'm not overstating the danger, but the fact that scientists are increasingly tracking this metric at all, and that events approaching more dangerous wet bulb thresholds have become more frequent globally in recent years, is part of why extended humid heat waves like this one are getting more serious attention from researchers than they might have received a couple of decades ago. Let's talk about who is actually most at risk during an event like this, because heat waves have a reputation, unfairly I think, as a relatively mild hazard compared to something dramatic like a tornado or a hurricane, when in reality, heat kills more people in a typical year in this country than almost any other weather hazard combined, precisely because the danger is quiet and cumulative rather than sudden and dramatic. Elderly individuals are at significantly elevated risk, partly because the body's ability to regulate temperature and sense thirst naturally declines with age, and partly because a lot of elderly people live alone and may not have reliable air conditioning or may be hesitant to run it due to cost concerns. Young children are also at heightened risk because their bodies heat up faster than adults, and their ability to communicate that they're in distress is more limited. People with chronic health conditions, particularly heart disease, kidney disease, and diabetes, face elevated risk because those conditions can impair the body's ability to handle additional heat stress, and several common medications for these conditions can further reduce the body's ability to regulate temperature or increase dehydration risk. And critically, anyone who works outdoors, whether that's construction, agriculture, landscaping, or any other outdoor labor, faces direct, sustained exposure during exactly the hours when conditions are most dangerous. And I want to specifically ask employers and supervisors watching this to build in real rest and hydration breaks during the peak heat hours over the next several days, because the productivity cost of doing so is genuinely trivial compared to the alternative. I also want to talk about why this event is going to feel noticeably worse in cities than in surrounding rural areas, because there's a real, well-documented phenomenon behind that difference called the urban heat island effect. Cities are covered in concrete, asphalt, and buildings, materials that absorb heat throughout the day far more efficiently than natural vegetation and soil, and then release that stored heat back out slowly overnight, instead of allowing the area to cool down the way a grassy or forested area would. On top of that, cities generally have less tree cover to provide shade and less vegetation to provide the natural cooling effect of evapotranspiration, and they have concentrated sources of additional heat, vehicle exhaust, air conditioning units venting hot air outside, industrial activity, all adding to the ambient temperature. The net effect is that a major city can run anywhere from a few degrees to, in the most extreme cases, nearly 10 degrees warmer than the surrounding rural countryside, especially overnight, which directly ties back into that dangerous elevated overnight low temperature problem I talked about earlier. If you live in a dense urban area, particularly in a neighborhood with limited tree cover, understand that your local conditions during this event are likely running warmer than whatever the official reporting station at the airport on the edge of town is showing. So don't assume the forecast high for your metro area fully captures what your specific block is actually experiencing. I want to touch briefly on the broader impacts of an extended heat wave like this beyond just personal health, because it matters for a lot of people's daily lives over the coming days. Electrical grids across the affected region are going to be under significant strain as air conditioning demand spikes simultaneously across huge population centers. And that raises a real possibility of localized power outages in some areas if demand outpaces what utilities can reliably supply, which is part of why having a backup plan, whether that's a portable fan that doesn't depend on the grid, extra water stored, or knowing where your nearest cooling center is, matters even if you have reliable air conditioning under normal circumstances. Agricultural areas within the heat dome are also going to see real stress on crops and livestock, particularly if this event combines with any existing dryness, since extended heat accelerates evaporation from soil and adds additional heat stress on top of whatever moisture deficit already exists in a given area. And infrastructure like roads and rail lines can also be affected, since extreme heat can cause pavement to buckle and rail tracks to warp or expand beyond their normal tolerances, sometimes forcing speed restrictions or temporary closures on some transit systems during the hottest stretches of the day. I want to spend a minute on heat-related illness itself because recognizing the signs early in yourself or in somebody around you can be the difference between a scary afternoon and a genuine medical emergency. Heat exhaustion typically presents with heavy sweating, cold or clammy skin despite the heat, dizziness, nausea, headache, and muscle cramps. And if you or somebody near you starts showing these signs, the response is to get to a cool or air-conditioned space immediately, loosen clothing, sip water, and apply cool, wet cloths to the body. Heat stroke is the far more dangerous escalation, and it is a genuine medical emergency requiring immediate action. Signs of heat stroke include a body temperature above 103 degrees, hot, dry, or unusually flushed skin, sometimes with an absence of sweating even though the person is clearly overheated, a rapid, strong pulse, confusion, slurred speech, or loss of consciousness. If you see those signs in anyone, call emergency services immediately, move the person to a cooler location, and try to lower their body temperature with cool water or ice packs while you wait for help to arrive, because heat stroke can cause permanent organ damage or death within a relatively short window if it isn't treated quickly. Let's talk about practical steps for the next several days, because I always want to leave y'all with something actionable rather than just a list of dangers. Hydrate proactively rather than waiting until you feel thirsty, because thirst is actually a lagging indicator that your body is already somewhat dehydrated. Limit strenuous outdoor activity to the early morning hours if you can, since that's typically the coolest part of the day, even during an extended heat wave. And avoid the window from roughly late morning through early evening, when heat index values are climbing toward their daily peak. Never, under any circumstances, leave children or pets in a parked vehicle, even for a few minutes, because vehicle interiors can climb to dangerous temperatures shockingly fast, sometimes gaining 20 degrees or more in just the first 10 minutes, even with a window cracked. Check on elderly neighbors, relatives, or anyone you know who might not have reliable air conditioning, because a brief phone call or visit to make sure somebody's cooling system is working and that they're staying hydrated genuinely saves lives during events like this. And if your own home's air conditioning isn't reliable or isn't available, most communities open designated cooling centers during extended heat events like this one, so check with your local government or library system for locations near you. I do want to touch briefly on how this heat pattern interacts with the severe weather side of what we normally cover on this channel, because it's relevant. Heat domes like this one tend to suppress organized, severe thunderstorm activity directly underneath the ridge itself, since the sinking air and capping effect that drives the heat also tends to prevent widespread storm development. But the edges of a heat dome, where that hot, unstable air comes into contact with cooler air being forced around the periphery of the ridge, can actually become a focus for stronger, sometimes severe thunderstorm activity, particularly across the northern tier of the country and the upper Midwest over the coming days as a frontal boundary tries to nose into the northern edge of this heat dome. If you're in that transition zone along the northern periphery of the ridge, it's worth staying weather aware for both hazards simultaneously, extreme heat if you're under the dome itself, and potential severe weather if you're closer to that boundary. And that's exactly the kind of shifting dual hazard stretch where having y'all call active matters, because if a severe thunderstorm or tornado warning fires for your address while you're focused entirely on staying cool, I still call your phone directly so you don't miss it. $14.95 for the year, so here's where I want to leave y'all this morning. This heat wave is not past its peak, it is still building, and based on the accumulated heat stress mechanism I walked through, along with the overnight low temperatures staying stubbornly warm, the next several days are very likely to bring the most dangerous conditions of this entire stretch, not the conditions we've already experienced. Treat the next few days with real seriousness. Hydrate proactively, limit outdoor exposure during peak hours, check on vulnerable people in your life, and know the warning signs of heat exhaustion and heat stroke so you can act quickly if you see them. I'm going to keep tracking this heat dome as it evolves over the coming days, including watching for any signs of when it might finally start to break down and allow some real relief back into the pattern. Subscribe to this channel and hit that bell so you catch that update the moment it comes. And share this video with anybody in your life who works outdoors, lives alone, or has an elderly relative nearby. Because a lot of people underestimate heat specifically because it doesn't look as dramatic on camera as a tornado or a hurricane, even though it's quietly one of the most dangerous hazards we cover on this channel. Stay cool, stay hydrated, check on your neighbors, and I will see y'all in the next update. I love y'all.